Besides representing function using diagram, using a mapping diagram just before, or a node, or an equation, we can also represent it using a graph, thanks to René Descartes, a French mathematician in the 17th century, that represent every relation or order path, that x, y, using a graph like this. So this is what we call Cartesian plan. And to plot this, y equal to 2x plus 1, you look at 1. 1 here is the y-intercept. So let's say it's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Negative 1, negative 2. So I'm putting in some numbers here. These are the number mark. So plus 1, that means starting from here, there's the y-intercept. 2x is the gradient. Gradient means, what is gradient? Gradient is rise over run. Remember that? That is a change in y over change in x. So from here, I go 1 step to the right, and then 2 steps up. 1, 2, right? So this is another point. This is a point of 1 and 3. Okay? And I can continue down here. 1 step right. 1 step left, and then 2 steps down. 1, 2. So this is another point, right? Negative 1, negative 1. So this is my graph. Right? Y equal to 2x plus 1. So the convention is that if the domain is not specified here, then we assume that the x here comes from all real number. If the domain is not specified, then x comes from all real number. To denote that these straight lines come from cover the whole real number line plane, well, either we don't do anything at the end, that means leave it as it is, or in some textbooks they use arrow at the end to indicate these lines go on forever and go on forever. Alright? So in this particular case, the domain is all real number. Right? Domain here is looking at this x here. If you start from here, would you be able to see the function? Well, yes, if you extend this, you say, oh yeah, the function is defined. And any point here, you go up, the function is defined. The next thing is that, what is the range? Well, the range is that, looking at this thing, looking from the way down here, for example here, starting down, well, would you be able to see the function? Yes, that is there. If you extend this, you will see that there is a value for that particular function. How about up here? Will you be able to see the value of the function? Well, in this case, yes, and so on. So the range here is indicated by the y, the vertical axis. The domain is the horizontal axis, right? Now looking at this one. You may want to take a few minutes to try out these questions. Find the domain and range of each graph. What is the domain here and the range? Domain and range, domain and range. Once you're ready, play the movie again. Okay, welcome back. Here, what is the domain of this? Well, the domain here is that if you look at the horizontal, right? Anywhere on this line, even if you start from here, if you extend this, you will see the function. So the domain exists. In fact, as stated before, if x is right here, x here is domain here is x is all real number. How about the range? Well, range, if you start from right at the bottom here, well, you're not going to see the function. The function doesn't exist. The first time you see the function is here. This is x equal to 0. Oh, sorry, y equal to 0. We're talking about range, y equal to 0. And as you go up, and you always see the function. Alright, you always see the function. So in this case, range here is y here is larger or equal to 0. Right? Something about naming. This, when every input has one output, this is called a one-to-one mapping or one-to-one function. This, for every value here, right? You see, for every x value, if I just pick here, x equal to 1, for example, I will get an answer, right? There's a one in, one output as well, right? But for that particular image of, let's say, 1 square is 1, for that particular image, right, there is actually two sources, right? There are two values of x's that give you the same value of y. That is x equal to 1 and x equal to negative 1. So this is not a one-to-one function. This is a one-to-one. This is called many-to-one function. In fact, for this particular case, it's only 2-to-1. Two values of x give you the same value of y. X equal to 1 and x equal to negative 1 give you the same value of y. Alright, how about this one? What does the domain look like? Well, the domain here is this. This is all the domain. Right, here you don't see anything. Here's a black dot, so it's starting from there. So the domain here is x here is greater or equal to 2. How the range? Well, the range here is this. Starting from here, this point, and it goes all the way down. Right? So here is y is less than or equal to, oops, sorry, this is 0, and then this is 2, because x here is 0, right? 0 all the way up, and then y is less than or equal to 2. Okay? Less than or equal to 2. Over here, what's the domain? Well, the domain here is this, up to this part. See, the dot here means inclusive. Open dot means not included. So this is a black dot, means included. So here the domain here is 0, from 0 to 360 inclusive. And the range here is, range actually is only go from negative 1 to 1, right? Negative 1 to 1. So this is the range. So range here is from negative 1 to 1, also inclusive. Inclusive means black dot. If it's not inclusive, then you have to use it this way. So for example, if I draw the graph like this, and I put in like this, and then go all the way up, like that. And here is negative 1, here is 2, for example. So in this particular case, the domain here will be written as this part, let's say negative 1, x, so not inclusive, so not included. And if I have to write, well, what this number is, let's say here is 5, then the range here is also from, range here will be open circle to open circle here. Alright, and then range in this case will become 0, greater than 0 but less than 5. So that would be the range, and that's the domain. Alright. Okay, thank you very much, and I hope you learned what it means by having a function. I hope that you have learned what is domain and range, able to identify domain and range from graphical diagram like this, and you're able to distinguish inclusive and not inclusive from whether you have a black dot inclusive using this symbol and not inclusive this kind of symbol. Alright, thank you very much.